Welcome to The Explainer. Today, we are absolutely unlocking one of the most important topics in geometry, quadrilaterals. And look, if you've ever found them just a little bit confusing, get ready, because we're going to see them in a whole new light. Let's be honest, has this chapter ever made you feel kind of overwhelmed in class? If the answer is yes, trust me, you are not alone. It's one of those topics that can seem way more complicated than it actually is. But what if I told you the truth? It's one of the most logical and, straightforward chapters in all of math. It's all just about simple rules building on each other in a really cool way. So, let's dive in. Okay, first things first, we gotta lay the foundation. We're gonna start with a super simple blueprint that every single shape we talk about today is built from. And that's really it. At its heart, a quadrilateral is just any closed shape with four straight sides. That means four sides, four angles, and four corners, which, we call vertices. It's as simple as that. So these are the basic parts of any quadrilateral you'll ever meet. You've got the four sides, right? The four angles on the inside, the four corners or vertices, and then these two lines called diagonals that connect opposite corners. These are literally our fundamental building blocks. And here it is. This is the golden rule, the one thing you absolutely have to remember. It doesn't matter how weird or stretched the shape is, if it has four sides, the four angles inside will always add up to 360 degrees. Seriously, it's non-negotiable. All right, now let's see how these basics build into something really cool. Think of it like a family tree of shapes. We're going to start with our great ancestor, the basic quadrilateral, and watch how just adding a few simple rules creates all of its descendants. So, picture any random four-sided shape in your head. Now we applied just one little rule. Make one pair of opposite sides parallel to each other. And boom, you've just created the first child in our little family, the trapezium. Okay, so what happens if we get a little bit stricter with our rules? Instead of just one pair of parallel sides, what if we make both pairs of opposite sides parallel? Well, the shape evolves, and it becomes a parallelogram, a super important member of this family. Now, this is where it gets really interesting. The parallelogram is kind of like the parent of three very famous, very special shapes, and each one is created by adding just one more specific little rule. So first up, the rectangle. You just take a regular parallelogram and you straighten out one of its corners until it's a perfect 90-degree right angle. That's it. And what's cool is that one little change forces all the other angles to also become 90 degrees. And just like that, you have a rectangle. And next up is the rhombus. Okay, again, we start with our parallelogram, but this time, forget about the angles. Instead, we're going to enforce a new rule. Make all four sides the exact same length. And there you have it, a rhombus. So what about the square? Well, the square is the ultimate combination. It's a special kind of parallelogram that inherits the rules from both of its siblings. It takes the perfect 90-degree angles from the rectangle, and it takes the equal sides from the rhombus. It's pretty much the most specialized shape in the whole family. Now, because the parallelogram is the parent of all these important shapes, it has some incredible built-in properties. I want you to think of them like its genetic superpowers. And knowing these four is the key to solving pretty much any geometry problem you're going to face. Okay, this is the slide you want to screenshot, memorize, tattoo on your arm, whatever works. These four properties are the secret code. In any parallelogram, 1, opposite sides are equal, 2, opposite angles are equal, 3, a diagonal splits it into two identical triangles, and 4, the diagonals cut each other into perfect halves. You master these, and you've basically mastered this whole chapter. Okay, I know that was a lot, so let's just put it all together real quick. Here is the entire family tree in one simple, clear guide. This is your final cheat sheet. See, this chart just lays out the entire logic. It's not about memorizing a bunch of random disconnected shapes. It's a story of evolution. Each shape is just a more specific, more rule-bound version of the one before it. It all flows right from that simple four-sided blueprint we started with. So there you have it. You've got the blueprint, you understand the family tree, and you know the parallelogram's secret superpowers. You officially have all the tools you need, so the only question left is, which one are you going to use to solve your next problem?